Shall we start? An alpha particle of mass charge is situated in a uniform electric field. There is a charge in electric field means there is acceleration. Okay, and acceleration is given by A equal to QE by M. This is the explanation for, or this is the equation for acceleration. And you don't have to study, you don't have to read the numbers. When you read numbers, you won't get clarity, but you will be killing your time. So as far as possible, try to avoid reading numbers. Okay. The velocity of the particle at the end of this velocity displacement means v square equal to u square plus 2as. U square plus 2as starts from rest, initial velocity 0. Substitute this in this, v square equal to 2 into acceleration is QE by M into displacement. Now v square equal to 2 charge 3.2 10 to the power of minus 19. Electric field 1.6 10 to the power of 5. Displacement 2 10 to the power of minus 2 by mass. Mass is 6.4 10 to the power of minus 27. Fine. Left hand side there is v square. Calculator is not allowed, isn't it? So let us solve this without calculator, and it is not required. See, 3.2 into 2 is 6.4, gone. 1.6 into 2, 16 32, 3.2, 10 to the power of. Observe, odd number, second odd number, third odd number means 10 to the power of is an odd. Left hand side is v square. So don't go to take square root of this when you have odd number. Make sure that this is even. So give 1 0 to this. It becomes 32 10 to the power of even number. Fine. Now velocity equal to 16 root of 16 2 10 to the power of even number. See, 4 root 2. Don't worry about 10 power. 4 root 2 is there in this option. Now you don't have to worry about this because they have given it is 10 to the power of 5, isn't it? So if you carefully solve this, you will end up with 10 to the power of 5. So it is 4 root 2 10 power 5. Now if you are okay with this explanation, please skip the explanation and go to next question. Let me give detailed explanation of this. See, alpha particle is a charged particle, and charge in electric field. Charge in electric field means force equal to charge into electric field. Second law says, Newton's second law says, this force is also equal to m into a. Therefore, acceleration is QE by m. So that I have used here. Next, if there is an accelerated motion, then final velocity, time, displacement, these are involved. Velocity time, final velocity time means v equal to u plus at. Velocity displacement means v square equal to u square plus 2as. St means s equal to ut plus half at square. See, velocity in some displacement displacement velocity means velocity displacement means this equation. That's why I directly picked this equation. See, you will have a number of equations, but you should know which equation to pick or which formula to pick. For that, you should thoroughly go through the question. And with little effort and practice, it's easy to get the equations. Velocity, acceleration. Here we understood that it should be accelerated motion. So, v square equal to u square plus 2as. Starts from rest means initial velocity gone. Substitute and simplify. Fast pace. Two identical conducting balls A and B have positive charges Q1, Q2. Let Q1 be equal to 1, Q2 be equal to 3. Easy to solve. But Q1 not equal to Q2. Q1 not equal to Q2. The balls are brought together so that they touch each other and then kept in their original positions. The force between them. Force is directly proportional to product of the charges. Now, these two are charges. Therefore, force is proportional to product of the charges. 3 into 1, 3. Now, they are brought in contact. Total becomes 4. Again, when they are separated, this 4 splits into 2 equally, 2 and 2. This is initial, this is final. Product of the charges is 2 into 2, 4. See, before product of the charges is 3, so force is less. After contact and separation, product of the charges is force. So this force should be greater. The force between them is greater than that before. Now let me give one more explanation if they are opposite charges. Okay, the case changes. Opposite charges. Now opposite charges Q1, Q2. One is 4, the other one is minus 10. Initially 4 and minus 10, product of the charges is 40. Force is directly proportional to product of the charges. When they are in contact, 4 minus 10 becomes minus 6. Then separated. 6 becomes minus 3 and minus 3. Now product of these two is product of the magnitudes of the charges. 3 into 3, 9. See, initial force is 40, final force is 9. So force decreases. Opposite kind means after the contact force decreases. Same type means after the contact force increases. So in this problem, when you start reading two identical conducting positive charges means same type, you should be alert. If it is same kind, then you'll get answers like this. Now, why did I take numbers? So to solve such problems using numbers, it's very easy. Either you can take 2 and 4 even numbers. So if these two are the charges, when they are in contact, it becomes 6. When they are separated, it becomes 3 and 3. Isn't it? Now, let me take numbers like this. 4 and 5. If these two are in contact, total charge is 9. When they are separated, we get 4.5 and 4.5. See, unnecessary fractions, nothing but fraction of a number. So we can get the answer, but it takes some time. That's why try to take both even numbers or both odd numbers. If they are odd numbers, something like this, 1 and 3. When they are in contact, 4. After the contact, 2 and 2. 4 splits into 2. See, these two are odd numbers. So experience says, or little practice says, try to pick numbers like both even or both odd. Okay. This is a beautiful problem. Just go through once. Two small spheres of masses m1 and m2. They are suspended from these 2 points at different levels. Lengths are L1 and L2. Angles are theta 1, theta 2. Because these 2 are charged, there is repulsion between these 2. These spheres can carry charges Q1 and Q2 respectively. The spheres are suspended such that they are in level with one another and the threads are inclined to the vertical at angles theta 1, theta 2 as shown. Which one of the following conditions is essential if theta 1 equal to theta 2? Now, first let me solve. After that, let me give explanation. This is m1g, weight. Because of 2 charges, there is repulsion. This is force of repulsion. This is tension in the string T. This is vertical component of tension. Theta 1, this angle is theta 1. Then this component is closer to theta 1, therefore T1 cos theta 1. Other component is T1 sin theta 1. Similarly, let us identify forces. F, this is the force of repulsion. This is m2g. This is tension T. This tension is different because m2g. This is T2. This tension is resolved into 2 components. This component is closer to theta, T2 cos theta 2. This component is away from theta, therefore T2 sin theta 2. So we identified forces. Now, these 2 are equal and opposite forces. They constitute action-reaction pair. If 2 charges are there, then this exerts force on this exerts force on this, and they are always equal and opposite. That you know. Therefore, this force should be equal to this force. If this force equal to this force, then this should be equal to this. It's given theta 1 equal to theta 2. Angles are equal. If theta 1 equal to theta 2, then T1 should be equal to T2. T1 should be equal to T2. If T1 equal to T2, theta 1 equal to theta 2, then this should be equal to this. Nothing but m1 equal to m2. Irrespective of magnitude of charges, we get m1 equal to m2. Where is that? m1 equal to m2? Yes, m1 equal to m2. Identified trap here. Number of lines in the problem. So to read and understand, it takes more than 1 minute. Doesn't matter. We can save time in some other question and we can utilize that time here. Now, let me give explanation how to get these forces. Okay. This is a string, sphere. This is one more string with identical sphere. Both are charged. Both are charged. Because of charges, let me represent that by plus and plus. Because of charges, there is repulsion. Okay. So this is the force of repulsion. First, we should find forces associated with the system. This is Coulomb's force, F. If charge is asked, you have to find force, and that force will have charge term. Okay. Next, this is weight, M into G. Because of these two, there is tension in the string. So this is the tension T. Now, let us find vertical and horizontal components of the tension. Let me draw a line here. If this angle is theta, then this angle is theta. Alternate angles, right? This component is closer to theta. See, this component is next to theta. Next to theta means T cos theta. And this component is away from theta. T sin theta. So first we found three forces, F, mg, tension. Then tension is resolved into two components, T cos theta, T sin theta. If this system is in equilibrium, then this force is equal to T sin theta. So we can write T sin theta equal to F, Coulomb's force. And vertical components are equal. T cos theta should be equal to mg. So T cos theta equal to mg. So this is how to get equations. Next step, if you carefully observe, if I divide one by the other, then tension get cancels, this becomes tan theta. So tan theta equal to Coulomb's force by weight. Tan theta equal to Coulomb's force by weight. So these are the few equations that we get in this situation. Two insulating threads, two conducting spheres, they are suspended from the same point. In such cases, and if they are charged, okay, in such cases we have to find the forces, and according to the given condition like this, we have to solve the problem. Now students, you can go back and go through the explanation of this. You will find all these forces, and then you will see how to get this answer, M1 equal to M2. Two identical charged spheres of material density rho suspended from the same point by inextensible strings of equal length. Make an angle theta between the strings. When suspended in a liquid of density sigma, the angle remains the same. The dielectric constant K. You know dielectric constant is always greater than 1. Nothing but epsilon r is greater than 1. Epsilon r is greater than 1. Okay. Now, observe these four options. Rho minus sigma, numerator is decreasing means this is not the answer. Denominator is greater means this ratio is less than 1. This is not the answer. So we have to find between these two. There is a material of density rho in a liquid of density sigma. Then what matters is density of the object minus density of the liquid. So among these two, this is found in this. Therefore, this should be the answer. Now, let me give explanation why this is the answer. If there is a guesswork, make sure that there is proper logic behind the guesswork. So without proper logic, you just don't go to guesswork. Okay, that doesn't work. Now, these two are the strings. These two are the spheres suspended from the same point. This is mg. Let us identify forces. Mg. Because of charges, this is the repulsion force F, and this is tension in this string T. This tension is resolved into two components. T cos alpha. Let this be alpha, and total angle is theta. Total angle is mentioned. Okay, done. And the other component is T sin alpha. So T sin alpha is equal to F. T sin alpha equal to F, and T cos alpha is mg. But m is mass is in terms of density. Mass is density volume into g. Therefore, T cos alpha is rho volume into g. Now, these two spheres, second case, these two spheres are in a liquid. This is a container with liquid. But still, this angle remains same, theta, theta. If it is a liquid with dielectric constant K, then the effect of force decreases. That you know. If effect of force decreases, then they should come closer. But here angle remains same. Angle remains same means the effect of dielectric constant is nullified by the buoyancy by the liquid. Okay, liquid of density sigma. Now let me identify forces. This is m into g. This m into g is density of the object minus density of the liquid into volume into g, and this mg is balanced by T cos alpha. So T cos alpha is sigma rho minus sigma is relative density volume into g. Not relative density, effective density. Effective density. And then this force F, force between these two, is equal to T sin alpha. T sin alpha. And this is force in a medium. Therefore, now force in a medium is force by K. See, T cos alpha is equal to mg. T cos alpha equal to weight. T sin alpha equal to force. T sin alpha equal to force. In this case, force by dielectric constant. Now, divide one by the other. Divide this by this equals force rho Vg. What I want is dielectric constant. So dielectric constant K equal to, take this rho to the other side, rho by rho minus sigma. So this is the dielectric constant. So that's why we took this. The electric field at a point due to an electric dipole on an axis inclined at an angle theta less than 90 degree to the dipole axis is perpendicular to the dipole axis if the angle theta is. Now, there is a dipole, plus, minus, center of the dipole. This is the point P. This is radial component of the electric field. Let me denote it by ER. This is transverse component I have to draw. But resultant of those two is, just observe, at an angle theta is perpendicular. So this is the resultant electric field E. So this resultant electric field should be perpendicular to the dipole axis. This resultant electric field should be perpendicular to the dipole axis. And this angle is phi. This angle is theta. Now, this is radial component of electric field. This is transverse component of electric field, perpendicular to this. Resultant of these two gives this. Okay. Resultant of these two is E. Now, bring this here. If this is phi, this should be phi. Observe, theta plus phi equal to pi by 2, 90 degree. Therefore, phi is 90 minus theta. Phi is 90 minus theta. And what is the expression for tan phi? This is a point other than axis and the equatorial plane. General case. General case means tangent of this angle. Tangent of this angle equal to half of tan theta. Half of tan theta. Phi is 90 minus theta. 90 minus theta, tan 90 minus theta. 90 minus theta is in first quadrant. Since 90 is there, tan becomes cot theta. All are positive in first quadrant, equal to half tan theta. What we want is theta. See, cot is 1 by tan. Take tan to this side, tan square. Tan square is 2. Tan square equal to 2. Therefore, theta equal to tan inverse of root 2. Tan inverse of root 2. Now, let me give explanation. Why this is called radial component, why this is called transverse component, and what's the relation between these two, theta and phi, and also magnitude of electric field. Positive, negative. These two are the charges. Center of the dipole. This is a point not on the axis, not on the equatorial plane. Axis equatorial plane is there in our syllabus, isn't it? Now, the resultant electric field, there is a resultant electric field here because of positive and negative charges. That electric field is resolved into two components. So, which are the axis means? One should be along this, call it radial component, ER, radial. And perpendicular to this, another axis. Since it is perpendicular to radial, call it transverse component, ET, transverse. Complete the parallelogram. This is the resultant electric field. Now, reverse explanation. Because of these two, this is the resultant electric field E. Resolve this into two components. This resultant electric field makes an angle phi with respect to radial component, phi. And this point P, this is the shortest distance between center of the dipole and point P. This imaginary line makes an angle theta with respect to dipole axis. This is dipole axis. So, this is angle made by this line with respect to dipole axis. Now, magnitude of electric field. Magnitude of electric field at P is given by 1 by 4 pi epsilon naught into P root of 3 cos square theta plus 1, this angle theta. So this is the magnitude of electric field at point P. Now direction. How to decide direction of this electric field? That is by phi. So expression for phi, tangent of that angle equal to half of tan theta. Half of tan theta. So tan phi equal to half of tan theta gives direction, and this equation gives magnitude. So this is also discussed in synopsis. Okay, just go through synopsis once, come back and try to solve.